All right, everybody, welcome back. Today what we're going to do is we're going to work on writing cubic equations from a few points. Now, we've done something similar like this in the past where we are given roots like this. We have negative 2, 0, and 1, 0. Now, our 1, 0 has a multiplicity of 2, so it tells us there are two of them. And what that really means is if we were to expand this out, we've got 1, 0, and 1, 0. Again, two of them. All right, given that we have these solutions of negative 2, we have 1 and 1. That means factors of x plus 2, x minus 1, and x minus 1. Now, in the past, what we've done is we've gone ahead and we have multiplied these all out, which is great. If we wanted to, we could distribute these, and we'd end up with something similar. Now, if I multiplied these out, that might be a little bit easier to start with. We have x plus 2 still. But then we have first, outer, inner, last, which will become x squared minus x plus 1. Or x plus 2 times x squared minus a 2x plus 1. And then we can distribute into that last one more time to give us x to the third minus 2x squared plus 1x. And then do the same thing with our 2 plus 2x squared minus 4x plus 2. And a final answer of x to the third. Our x squares actually cancel, and we get minus 3x because we have plus 1 minus 4, and then a plus 2. So this will be our final polynomial. Now, we're going to do something similar, but what we're going to do is we're going to be given 4 points like this. So it says write a cubic function with the following points. We have 0, 12, negative 3, 0, negative 1, 0, and then 2, 0. So before, we were taking only our x-intercepts and writing equations. Now, this is a little bit different, but because we're told that it is a cubic, we're going to follow the same idea. So this first point is a special point. This is actually our y-intercept. But the key idea is it isn't an x-intercept. So with these other x-intercepts, I can write their factors of x plus 3, x plus 1, and then x minus 2. Now, what we're going to have to do is we need to consider the fact that there could be some a value in front, and we don't really know what it is. We only know that we're going to go through these x-intercepts, which we have in our factors here. Now, because we know we go through the point 0, 12, we can find out what that a value is. So if I take the y value, and then I plug in the x value that I know I am given of 0 here, I can plug it in for each of my x values in my factors. That should be a 0 minus 2. And now we can simplify. So I have 12 equals a times 3 times 1 times a negative 2. Or 12 equals 3 times 1 times negative 2 is a negative 6 with an a. And if I just solve for that a value now, I get negative 2 equals a. So that tells me my equation is going to be y equals an a value of negative 2. And then we have those factors, x plus 3, x plus 1, and x minus 2. Now, we don't exactly ask our students to multiply this out, but you could, and you could get the polynomial just like we had above here. The only difference is we'd have to distribute, in this case, a negative 2 into everything, which we could even do at the end there and get our answer. So it's very similar to that idea. The only other difference is we're given a point that is not an x-intercept, which is this one here, that we had to use towards the end to find out what that a value would be, what that leading coefficient would be in our function. Now, most of our examples are going to look just like this. So here's our next one. We've got to write a cubic function with the following points: 0, negative 2, 1, 0, 1, 0, and 2, 0. So same idea. We have y equals, we don't know what that a value is yet, that value in front. And then we've got x minus 1, that is 1, 0 as a factor. We've got another one of those. And then we have x minus 2 for our last one. Now, I need to find out what that a value is. So I'm going to take this value and plug in the y value and then the x value for each of my x's. So I get negative 2 equals a times 0 minus 2, 0 minus 1. Actually, did this a little bit backwards. We have a 0 minus 1 first, 0 minus 1, and then 0 minus 2. Now, simplifying and solving, I get negative 2 equals a times a negative 1 times negative 1 times a negative 2. So I have negative 2 equals negative 1, and negative 1 is positive 1, times a negative 2 is a negative 2 with our a. So I solve and get an a value of 1. So it tells me my equation, at least in factored form, is y equals 1 times x minus 1. That's our first factor. X minus 1 is my second, and x minus 2 is my third. So this is where we're going to leave this for the most part. It really doesn't get much more complicated than that. Now, we could be dealing with fractional values, and that really wouldn't change anything we're doing. We just have to solve with fractions. So this is, for the most part, like I said, what our problems are going to look like. All we have to do is we start off in a factored form. So we take our x-intercepts, we make them into factors, and then we use that additional point that is not an x-intercept to find the a value of our function. And again, the reason that is there are lots of different functions that go through these same x-intercepts, but they could look very differently. This last one is the important one. That's the one that tells us the extra bit of information that we are going to need. So that's why we plug it in, we solve, we find the a value, and we get it by itself. And then we have the factored form of our equation here. And again, if we wanted to, we could multiply that out just like we did in our warm-up problem. But we're not really assessing on that right now because, we're assuming that you guys all have the skills to do that. Now, we've got one more. So I've got write a cubic function with the following points. So I have 0, 0, negative 4, 0, negative 1, 0, and then 1, negative 6. Well, this is an x-intercept, and actually so is this one here. But it is also a y-intercept. But the key part for us is we've got 3 x-intercepts, excuse me, and then an extra point. So start off the same way. Y equals the a value times, we'll have x minus 0 for that first one, x plus 4 for the second one, and then x plus 1 for the third. Now is where that extra point comes into play. Again, it's not an x-intercept. It's not even a y-intercept at this point, but we could use it the same way. I've got a y value that I can plug in, and I've got an x value that I can plug in for each of my x's, which will allow me to solve for my a value. Again, what we're trying to do is find the equation of a polynomial function that goes through all of these points. So now if I do this, I've got negative 6 equals a times, now it's going to be a 1 minus 0, 1 plus 4, and 1 plus 1. Same idea, go ahead, simplify and solve. We get negative 6 equals a times 1 times 5 times 2. Negative 6 equals a times 1 and 5. 1 times 5 is 5, times 2 is 10. And so now I'm going to divide by 10. And I end up with something that's going to simplify to a negative 3 over 5 as my a value. So this is kind of the example I was talking about. We have a leading coefficient that is going to be fractional. And again, that's fine. It doesn't really change a whole lot for us. Y equals, we have that a value. And then I can use those factors to write my equation in factored form. We've got x minus 0, x plus 4, and x plus 1. Now, that front one here, this front factor, really could just be written as y equals negative 3 over 5 times x plus 4 times x plus 1. And again, this is the factored form, so really we could stop here. What I want to do is I'm going to show you what this looks like if we were to multiply it out. Again, you might have to, you might not have to. It kind of depends on what you're being asked. So I'm going to FOIL these two factors first. I'm going to ignore my values in front for now. So first, outer gives me x squared plus a 1x, inner 4x, and then last is 4. So this is where I'm at right now. Again, I can't forget I've got that x in the front and that negative 3 over 5 with my y equals. So I have y equals negative 3 over 5 times x still, and I'm going to simplify this to give us an x squared plus 5x plus 4. And I'm going to distribute in that x value, y equals negative 3 over 5 times x to the third plus 5x squared plus 4x. All right, and now at the end here, if we wanted to get our polynomial in standard form, I would do the exact same thing, but now with my negative 3 over 5. And that will give me my final answer of y equals negative 3 over 5 x to the third. I have a negative 3 over 5 times 5, and that's going to give me a negative 3 x squared. And then negative 3 over 5 times 4 is a negative 12 over 5x. So this is the equation in standard form. Again, for the most part, I just ask my students to leave it in factored form, which would be something like this, or even more simplified, something like this one here. Okay, so all we have to do is if we're given different points to use to write an equation, well, we pull out the x-intercepts, and we're going to use those to write factors. Once we have factors, we know what a cubic should look like in standard form, or in factored form, excuse me. And even if it was a fourth degree polynomial, a quartic or fifth or sixth or a second degree, it really doesn't matter. Our idea and our approach would be the same way. We would take our x-intercepts and then write them each as factors, and they would follow the same idea. So let's say we had a quadratic, something to the second power. Negative 2, 0, and let's say 3, 0. Let's make up another 0.14. Well, again, we would start off like this. Y equals a, our factor, and our factor. So we'd have x plus 2 and x minus 3. And now we'd use the 1 and the 4 to find out what that a value is. And again, we'd have our equation in factored form, and we could multiply it out, just like we did before, to get our answer in standard form. Okay, so no matter how many different x-intercepts you're given, we can write a polynomial function with that many x-intercepts by using the same method. If you have negatives in front or fractions in front, it doesn't change any of the work that we're doing. We might just deal with, some not so nice numbers towards the end, as we saw right here. Okay, thank you for listening. And as always, if you have any questions or concerns, please feel free to leave a comment, and have a good day.